Good morning, students. Welcome to my YouTube channel, Understanding Concepts. Our today's topic is Serial In, Serial Out Shift Register. In Serial In, Serial Out Shift Registers, data bits enter the register one at a time and leave the register one at a time. One flip-flop for each bit to be handled. As you can see here, we are here considering a 4-bit register. That means we are using here the 4 flip-flops. 1, 2, 3, 4. These 4 blocks represent the flip-flops. So the data in the register will enter one by one and leave the data from the register one by one. It's a 4-bit register because we are using a 4 flip-flops. So 4-bit register will store 4 bits in it. Movement can be left or be right because it's usually only a single direction in a given register. If here you can see the direction is left to right, the data is entering from the left hand side and leaving the register from the right hand side. And on the other hand, if we are having a right to left data movement, then in this 4-bit register, the data is entering from the very right hand side and leaving the register from the left hand side. Here you can see the block diagram for serial in, serial out shift register. Asynchronous preset and clear inputs are used. Here we can see this is a preset control and a shift pulse and a clear control signals. This represent the serial in, serial out. These basically signals are used to preset, means the initial values are being set in the register, and clear is used for to clear the shift register. Like if we don't want anything to be stored in the thing, we will give a signal on the clear, and that shift register will be completely empty. And here you can saw the generalized diagram for the shift register, and here we are using the SR flip-flops, and basically we are connecting the input, a single input, to the S and the same input to the R through a NOT gate. That means here we are using these as the D flip-flops. The input values moved to the output of the each flip-flop with the clock pulse. When we will provide the clock pulse, then the output will be there according to the inputs. Here you can see we are using the 4D flip-flops, and we have arranged them in a manner to make a 4-bit shift register. This shift register will behave as a serial in, serial out shift register. So here the output from the each block will come when a clock pulse will be provided. And the serial in, SI determines the data that goes into the leftmost flip-flop during the shift, and the SO, that is a serial output, is taken from the output of the rightmost flip-flop. Here we can see the diagram where we will simplify the operation of the serial in, serial out shift register. Suppose we are here actually taking a 4-bit register, so we can shift a 4-bit data into the register. So we will take an example of a 4-bit data, that is 1011. Suppose we have to store this 1011 into the 4-bit register. So first of all, when the first clock pulse will be provided, here this is being symbolized that the clock pulse is 1. First clock pulse is being provided, then the this rightmost one will be shifted into the register. The flip-flop will contain the data of this input. After the when we will apply the clock pulse 2, that on the second clock pulse, this basically this one has been shifted here in the next flip-flop, and this next second one will be shifted in the shifter register. And now we are having here left 1 0 out of the register, and this 1 1 is being stored into the register. At the third clock pulse, this 1 here will be shifted in the next block, like you can see here, and this one is shifted in the next flip-flop, as you can see here, and this next 0 is being loaded into the first flip-flop. At the clock pulse 4, when we will provide the fourth clock pulse, then this one will be shifted into the next flip-flop like this, and this one will be shifted into the next flip-flop like this, and this 0 will be shifted to the next place in the next flip-flop, and the last one is being loaded into the first flip-flop. So with the four clock pulses, we have loaded 10114 4-bit data entirely into the shift register. So when we want to have the output, we will give the next fifth clock pulse. So the rightmost one, whether we can also have a 0 or 1, that depends upon the data only. So here as according to the example we are having 1, that one will come out of the register like this, and all these other 3 bits will be shifted in the right direction one by one. Like this one is being shifted here, this 0 is being shifted here, and this one last one, leftmost last one, is being shifted in the next flip-flop, and this flip-flop is now empty. So here we can see a diagram that shows a 4-bit sequence, and where we are here having the 4 D flip-flops connected in a series manner, and this diagram shows that it's a serial in serial out shift register. And here we are considering an example like we are having a 4-bit data 1010 to be shifted into the shift register. So we can see now in this first case, the register is initially clear. That means we are not having any value stored in the register. So when we will provide the first clock pulse, here the clock 1 is being provided, then the data is basically 1010. The rightmost bit, that is 0, that will be stored in the first flip-flop. Now you can see this flip-flop has been blue in color. That shows that it is now being loaded with some value. When we will provide the second clock pulse, that is a clock pulse 2 will be provided here, then here like we can see the clock pulse 2 is being provided. The second data bit, that is 1. Here we can see the after the 0 we are having this 1 that will be loaded in the here in the this flip-flop, and the data that was being previously loaded into the flip-flop, that is being shifted to the next one. Here this 0 is being loaded over here, and this 1 is now in the first flip-flop. And when we will provide the clock pulse number 3, at the third clock pulse, the next bit, this 10 will be ready to be shifted over here. Now this 0 will be loaded in the next flip-flop, and this 1 will be loaded in the this one flip-flop, and this 0 third bit is now being loaded into the flip-flop. At the fourth clock pulse, the last bit 1 is here to be loaded, and when the fourth clock pulsing be provided, then the data in this flip-flop will be shifted into the next one flip-flop. Like now you can see here this one flip-flop is also blue in color. That means now it is being loaded. Here the output is showing as 0. The data in this flip-flop is being shifted into the next one, like here, and now you can see here is a 1. Now the data here that was previously 0 being loaded over here, now that is being shifted to the next flip-flop, that is now here in the second flip-flop, and the last bit 1 is now loaded into the this flip-flop. Now you can see all the 4 flip-flops are in blue color. Now that means data of the 4-bit 1010 is now almost basically is being loaded into the shift register, and we have loaded this shift register in a serial manner. Now we will learn how to be unloaded the shift register in a serial manner also. Now we can see here the 4 flip-flops are in the blue color. That means it shows now all these blue flip-flops are loaded at a time, and the value that is being loaded into the shift register is 1010. So now when we will provide the 5th clock pulse, the data will shift towards the right, and this that is the bit in the last flip-flop will come out of the shift register, and all other data in the shift in the flip-flops will be moved towards the right. Now you can see here this one the flip-flop from the very left hand side is now empty. Now you can see with the clock pulse, next clock pulse, that is a clock 6, the data is being now shifted one more towards the right with the one more clock pulse. Now you can have the output 0 and 1 here, and the next 1 and 0 being shifted to the next flip-flops. Now at the clock 7, these 3 clock those flip-flops are now empty, and data is being shifted to the right hand side. Now at the 8th clock pulse, all the data we have got at the output, that is 1010, and you can see now these all the 4 flip-flops are not blue in color. That means they are totally unloaded now, and we have unloaded the shift register in a serial manner also. So this was the all about the serial in serial out shift register. Thank you.